All right, hi folks, this is Larry Anselino. I'm recording a video for Objective 8 in MATH026. And I want to go over a few of these topics, and most of these have to do with either graphing or finding domain and range. So I'm going to make sure to do a few examples. Why don't we start out here, graphing a line given an equation. All right, well, they're giving us an equation of a line here. And it turns out when you go to graph this, it's going to end up graphing as a straight line. So what we'd like to be able to do here is take this equation and represent it on this XY axis. All right, well, there's a couple of ways you could do this. Let me give you one way. You could make up your own XY table. And I could pick different values of X at random, plug them into the equation and solve for Y, and that would give me XY points I could plot on the graph. There's another way I could do it. I could graph this using a method called the slope-intercept form. Let's do it both ways. So let me do it both ways. First, I'll do it using an XY table. All right, now, before I remember, the method here is I'm going to randomly pick numbers for X, plug them into this equation, and solve for the corresponding value of Y. All right, now, before I pick X values, I want to try to do this in a smart way. Because whatever value I pick for X, it's going to end up being multiplied by the fraction 1/5. All right, well, first thing I'm going to do is I'm going to pick X equals 0, because that's going to make the arithmetic easy. So let me go to this equation, which is Y equals 1/5 X plus 4. And I'm going to replace X with 0, because that's the value I just selected. Remember, you don't have to pick 0. You can pick a different value, but I'm picking 0 to make this as easy as possible. 1/5 times 0 is just 0. So that's 0 plus 4. So that's 4. So this Y value is going to be a 4. All right, well, I need two different values for X if I'm going to plot this line. So I need another value for X. Again, what I'm noticing here is X is going to be multiplied by 1/5. If I was to pick X equal 3, let's say, that would not be a good choice, because then I would multiply 1/5 times 3, and I would end up with a fraction 3/5. I don't want fractions here because it's going to make it hard to graph. So how about if I pick X equal 5? Let me show you why that's a good choice. Well, if I have 1/5 times 5, this just equals 1. So that's a whole number. So then I'm going to end up with Y equals 1 plus 4, or Y equals 5. So for this equation, what I would like to do is pick X to be multiples of 5. I could pick X to be 10 or 15 or 20, because then when I multiplied it by that fraction 1/5, I would still end up with a whole number. All right, well, what I have now are two XY points. From this first line in the table, I have 0, 4. And from the second line in the table, I have 5, 5. So all I need to do is go plot these points on the graph. So here's 0, 1, 2, 3, 4, 5. And here's on the x-axis 1, 2, 3, 4, 5. All right, well, let me go to 0, 4. You might remember the first number is the x value, and that tells you the horizontal distance to go. The second number is the y value, and that tells you the vertical distance to go. And we always start here at the origin when we're graphing these points. All right, 0, 4, that means go horizontally 0 and then vertically 4. So that just means go straight up 4. So here's the point 0, 4. All right, how about 5, 5? Well, that's telling me go horizontally 5 and then go vertically 5 and put a dot. Now I'm going to connect these with a straight line. This is the graph that I'm interested in. All right, but let me give you an alternate way to do this. Let me go back to this equation, Y equals 1/5 X plus 4. Well, if you go into the reference packet, you'll see there's a general form of an equation like this that says y equals mx plus b. M is the slope of the line, and this b is called the y-intercept. So let's graph this alternate method to graph the same equation. All right, well, in our example, notice that b matches up to 4. Well, if b matches up to 4, that tells me the graph must intercept the y-axis at 4. So I can start off putting a dot here. I know the graph has to intercept the y-axis at 4. Now I'm going to look at the slope. Well, the slope is 1 over 5. But the slope is defined as the change in the vertical direction. Sometimes you'll see it change in y over the change in x. That's the change in the horizontal. So this 1 over 5 is really telling me to go up 1 and over to the right 5. And I do that starting at the y-intercept. All right, so here's what I'm going to do. I'm going to start here at this y-intercept. I'm going to go up 1 and over to the right 5 and put another dot. Well, I'm going to connect these 2 points with a straight line. Of course, I end up with the same line as we did earlier. So you can use either one of these methods to graph a straight line like this. What if the slope had been, let's say, -3 over 4? Well, if the top number is a negative number, remember that's the change in the y direction, then instead of going up 3, you would go down 3. And still go over to the right 4 because the bottom number is a positive 4. Okay, so this should help you graph these equations. Folks, please remember that you can click on this explanation. So here is the first way to graph this using the table method that we did. But if you click up here on another explanation, this is giving you the slope-intercept form that we talked about. So remember, these explanation buttons are going to be very helpful. All right, how about if we take a look at another example here? And this one is asking us to find the domain and range of this relation, which they really mean these blue dots. So first thing, let me just write down the XY coordinates for these blue dots. For this blue dot, it looks like it's -1, 3. Right, I'm noticing that I would go to the left 1 and up 3 to get to that point. So that's -1, 3. How about this point? Well, I'd go horizontally -3 and then go vertically -2 for that one. And for this one, it looks like it would be -1, -3. All right, now I need to know, what do they mean when they say domain? Domain really is asking you, what is the set of all the x values in the function? Well, in this example, the function is really just defined by these 3 blue dots. So they're really just asking me to list out the x values. Well, the x values are -1, -3, and -1. But when you write a set like this, you don't repeat elements. So I'm just going to write it as -1, -3. Okay, I wouldn't write -1 twice in a set, because in any set you only write the element one time. All right, what about the range? Well, the range is the set of y values. By the way, remember, these are written x, y. The x value always comes first. The y value always comes second in these xy points. All right, well, range, set of x values. Excuse me, set of y values for the range. So for this, I just have to look at the y values. Well, it looks like it's a 3, a -2, and a 3. So 3, -2, -3. The order doesn't matter when you write these elements in a set, so you can really write them in any order. And I know to use these curly braces because the problem said using set notation. Set notation means writing it inside curly braces like this. Okay, again, remember you can click the explanation button and it would explain how to analyze this kind of problem. Okay, let's go to another example. How about identifying functions from relations? Let's take a look at that one. Let me go identifying functions from relations. All right. So it says for each one of these relations, decide whether or not it's a function. So a relation really just means a pair, like you think of it as like an XY pair. So in this first one, let me come here. I could write this if I wanted to as J comma F, B comma A, V comma F, Y comma V. We call this a relation. You're just listing out these kind of XY pairs. But how do you know if it's a function? So how do you know if XY pairs represent a function or not? Well, there's a rule for this. The rule is any X value can only be matched with one Y value. Another way to think of that about this is you cannot have repeated X values. And when I say X values, I really mean the first element in the pair. Okay, let me come to this example, relation 3. All right, we want to know, is this a function or not? Well, the question you want to ask yourself, is the X value repeated at all? Well, let me take a look at the X values. There's a -8, there's a 1, there's a -2, and then there's a +8. Well, notice there's no repeats for the X. Well, if there's no repeats for an X, then yes, this is a function. By the way, you don't look at the Y values. Notice the Y values, there is a repeat. There's an 8 and an 8. But the Y value has nothing to do with determining it's a function. You only look at the first element, the X value, so to speak. Let me come to relation 4. Let me look at the X values. By that, I mean the first element. Well, here's a W. Here's a W. I'm going to stop right away. I'm seeing a repeated W, not a function. I can't have that first element repeat if it's going to be a function. Let me go here to this relation 2. Well, here's a -2 and here's another -2. I'm seeing a repeat for the X values, so this is not a function. All right, let me go here to relation 1. All right, I'm seeing a J, a B, a V, and a Y. Notice there's no repeats. So yes, this is a function. Remember, don't look at the Y values because you might look here and say, oh, here's an F and here's another F. But that doesn't matter. You don't look at the range. You only look at the domain if you're interested in the question about whether these relations represent functions. All right, let me come to a related topic on this one, and it's called the vertical line test. All right, so what we just did is we determined if XY pairs represented a function. But there's another question that comes up. What if you're looking at a graph? Does a graph represent a function? Well, there's a method to answer that, to this. It's called the vertical line test. By the way, this is in the reference packet if you You need to look this up. Here's what it says. Imagine drawing any vertical line. Draw any vertical line, that means straight up and down. If the line intersects the graph, I should say if the vertical line intersects the graph at more than one point, then the graph is not a function. All right, let me show you some examples. I think it's best to understand this using examples. Let me come down here to graph number 4. All right, I'm going to draw any vertical line I want. So here's a vertical line, here's a vertical line, here's a vertical line, and so on. Did these vertical lines intersect the graph at more than one point? I'm just going to draw one to make it a little easier to see what I'm talking about here. Let me just draw one vertical line. Okay, I'll draw it right here. Does this vertical line intersect the graph more than one point? Yes, it does. It intersects here and here. So if the line intersects more than one point, the graph is not a function. So this is not a function. Let me come up here to graph 3. I'm going to draw a vertical line here. Again, this intersects more than one point, not a function. Let me come down here to graph 6. Well, I could draw a vertical line here or here or here or here. Doesn't matter. It's only going to intersect the graph one point. So it's not violating this vertical line test. So this is a yes. This is a function. Okay, let me go to some of these points here. Remember, I'm going to draw any vertical line I want. Now, in this example, the function is defined just by the blue dots. But if I draw these vertical lines, it's not intersecting the graph in more than one spot. So, yes, this is a function. Let me come up here to graph 2. Well, I could draw a vertical line here. I could draw a vertical line here. But notice if I draw a vertical line here, it is intersecting the graph at more than one spot. So this is not a function for this one. Okay, let me go to the one more here, graph 1. Well, if I draw a vertical line here or here or here or here, it's not going to intercept the graph in more than one spot. What if I was to draw the vertical line here? Well, it's still okay, because when you see this empty circle, the function is really not defined there. The function is only defined where you see the filled in circle. So this is, yes, a function. Because a vertical line is not intersecting the graph more than one spot, at more than one point. So that means, yes, it is a function. All right, let me look at a couple more. How about, let's look at set builder and interval notation, because you're going to need this for some later examples. All right, it wants us to graph this on the number line and then write the set using interval notation. All right, well, let's break this up into two parts. Let's talk about the graph part of things. All right, now here's the way the graphing works. If you see a less than sign on an endpoint, for that you use an open circle. Sometimes we call it an empty circle. But if you see a less than or equal to, then you use a solid, sometimes we say filled in circle on the endpoints. So let's go graph this. All right, well, what this is really telling me is X is between 4 and 7. So when you see an X sandwiched in the middle like this, it's really telling you that X is in between these two numbers. So X is in between 4 and 7. All right, so here's what I'm going to do. I'm going to come to this number line. I'm going to highlight the 4 and highlight the 7. And then I show highlighting in between. So this is the way I show that all of the values, all of the numbers between 4 and 7 are valid solutions to this inequality they gave me to begin with. But do I make the endpoint for a filled-in circle or an empty circle? Well, notice with the 4 is just a less than symbol. If it's a less than symbol, you leave it as open. Let me go over to the 7, though. The 7 has a less than or equal to associated with it. That means I need a solid or filled-in circle. So this circle here on the 7 has to be filled in. Let me show you this on the explanation. It's probably easier to see the graph in the explanation. So let me show that to you. Here it is down here. So notice they've filled in, they've highlighted in between 4 and 7. They've made the endpoint at the 4 an open circle, and they've made the endpoint at the 7 a filled-in circle. Okay, so again, when you see the symbol of either a less than or greater than, that means use the empty circle on the endpoint. But if the symbol is a less than or equal to or greater than or equal to, that means use a solid or filled-in circle on the endpoint. All right, well, now they want me to write this in interval notation. So this is the graph, but they also want me to write this in interval notation. Well, the way I write that is I kind of write down the endpoints as I see them, 4 and 7, and you put a comma in between them. Now, you either have an option to put a parenthesis or a bracket. Well, for interval notation, you use parentheses if it's a less than symbol, but if it's a less than or equal to symbol, you're going to use brackets. So on this 4, I'm putting a parenthesis. And again, the reason I'm doing that is there was a less than symbol with the 4. On the 7, I'm putting a bracket. And the reason I'm doing that is for the 7, it was a less than or equal to symbol. All right. You might remember this from MATH026 if you took that course. All right, well, let's do a couple more examples here. How about if we do a couple of domain and range questions? And let me go to, let's do this, a continuous function. All right, so they're asking us here for the domain and range. And they want us to write it in interval notation. All right, well, here's what we have to do. For the domain, it's going to be the set of x values. Really, you're asking yourself, what about all the x values that would fall on this graph? So imagine you were thinking about all the x values on this graph. One way to imagine that is to put a ruler down on the x-axis and ask yourself, how far does the graph extend on the x-axis? Well, notice this graph is at x equal -3 here on the left side, and it extends over to x equal +3 on the right side. Right? That's the entire span of the graph in the horizontal direction. That's what we're looking for with the domain. So the domain in this example is going to be from -3. Whoops, let me start over again. The domain is going to be from -3 to +3. And now in interval notation, I have to know, should I use a parenthesis or a bracket? Well, when I look at this -3, it's a filled-in circle. You might remember if it's a filled-in circle, you use a bracket. So I'm going to put a bracket on this -3. For this positive 3 over here, notice it's an empty circle. Well, for an empty circle, we use a parentheses. So I'm going to put a parenthesis on that side. Okay, so again, what we did here is we've kind of looked at the span in the x direction. We notice this graph only goes from x equal -3 to +3. Because this was a filled-in circle on the -3, we used a bracket. Because this was an empty circle here on the +3, we used the parentheses. All right, so that's domain. Let's look at the other part of this, which is the range. Well, the range is the set of y values. So now what I have to do is put a ruler kind of on the y-axis and ask myself, how far does this graph extend up and down? Well, on the top here, it looks like it's going up to 4. So there's a y value here of 4. And what about on the bottom? Well, it's going down to y equal -5. And it does include -5 itself because of that solid dot there. So it looks like I'm going from -5 on the low end to +4 on the high end. Now, when it comes to the -5, because -5 itself is part of the range, I know that from that solid dot, I'm going to bracket here. On the 4, I could put my own dot here if I wanted to, just to make it a little clearer that y equal 4 is a point on the graph. So I'm going to put a bracket on that side too. Okay, let me go to the explanation just so you can see this a little easier to visualize. So let me get rid of my scribbling here. All right, so you can see what they did is for the domain, they put this red line. And notice this red line extends from -3 to +3. And here's the domain with the bracket on the -3 and the parenthesis on the +3. Let me scroll down to look at the range. For the range, they sketched out this red line. And notice it extends from -5 up to +4. And they put brackets on either side. All right, let me go to one more example here. How about if we do a piecewise function? All right, well, this is going to be the same idea. The only difference on this one is the graph is broken up into 2 separate pieces. All right, so let's take a look at this one. Let's do the domain first. All right, well, the domain, let me actually use their drawing because I think they would show the drawing a little nicer than I do. So let me go to the explanation. All right, so let's look at the domain. Remember, the domain is the span in the horizontal direction. So this graph spans this red portion here and this red portion here. So let's look at each red portion separately. Well, notice this part of the graph is going from -4. This is x equal -4. And this part here is x equal -3. And notice they're both open circles, empty circles. So that means we're going to use -4, -3 with parentheses for that left side of the domain. How about this other part of the graph here on the right side? Well, notice this is going from x equal -1 to x equal +5. And again, there's empty circles on either end. So we're going to put -1, -5 in parentheses. Now, when we have these 2 separate intervals, you usually put a U in between. The U means union. It's kind of like saying this domain is joined together for these 2 separate intervals. All right, let's take a look then at the range. The range is the vertical span. All right, well, one thing you might notice is when I look at the vertical span here, this vertical span actually includes this graph also. So I'm just going to focus on the right side of the graph here because that's going to give me the range that includes this other left side part of the graph as well. All right, well, I'm noticing that this is going from a y value of +1 on the top and a y value of -5 on the bottom. So when I write that in interval notation, you always write the smaller number first. So I'm going to write -5, -1. These are both empty circles. Empty circle means put a parenthesis on it. So the range is -5, -1. All right, hope this is helpful as you're working in Objective 8. Please let me know if there's any questions.